So now we already come to the very last subtopic of integration, which is the properties of definite integrals. For your information, there are a few properties of definite integrals that can help us when we are doing the integration of a function. So let's explore the properties and solve a few problems related to the properties of definite and indefinite integrals. So now we are in the final subtopic in the integration part, which is the properties of the definite integration. So in the previous video, we have seen about how to solve the definite and indefinite integrals, okay, and a few rules or formula for integration, either is a definite and indefinite integration. And now we want to see about the properties of definite integration. We have 6 properties that we want to explore here. Okay, I would just like to remind you what is actually the definite integration, where the definite integration involves the lower limit and upper limit of the integrals. Okay, it is different from the definite indefinite integrals, where we don't have any limits, so the final answer will be in the equation form plus with c, which is any constant. But the definite integration, usually the final answer will be in the form of value, where we need to substitute the lower limit and upper limit to get the final answer. So now I want to see first what is the properties that related to the definite integration. So the first one, if you have your lower limit and your upper limit equal value, for example, you have the lower limit is equal to your upper limit, so the integration of that function will be 0. Okay, let me give you one example here. Let's say you have to integrate from 2 to 2 x cubed plus 2x squared dx. Okay, so if you can see here, this one is called as definite integration because you have lower limit and upper limit, but the lower limit and the upper limit has the same value. So for this case, you don't need to proceed with the integration process, because it will automatically give you the value is equal to 0. Okay, let's learn why this happened. Okay, let's learn on why this happened. Okay, so for definite integration, we will integrate as usual our function here by using 2 techniques of integration. Okay, the first one here, x cubed, you integrate, you will get x to the power of 4, divide with the new power, which is 4, and then plus, and you integrate 2x square, you will get 2x to the power of 3 divided by 3. And because this one is definite, then there is no for you to put plus c, but you need to put the lower limit and also the upper limit. And then we will substitute the value of lower limit and upper limit to get the final answer for our integration. So the first one, we will draw 2 bracket minus and the second bracket here. Okay, the first bracket, you need to substitute the value of the upper limit inside your x. Okay, every x, you need to substitute with the upper limit. So what you have here is 2 to the power of 4 divided by 4 plus 2 multiplied by 2 to the power of 3 divided by 3. Okay, and then for the second bracket, you will substitute the lower limit. So again, 2 to the power of 4 divided by 4 plus 2 to the power of 3 divided by 3. So if you can see, this one and this one is the same value. So let's say you have the same value. Let's say if you calculate here, you will get the value as equal to, this one is 4. So 4, this one is 16 over 3. Okay, so 12, 28 over 3. So you get 28 over 3 here, minus with this one also 28 over 3. Of course, the final answer will be 0. Okay, this is the reason why whenever we have the lower limit of our integrals, equal to the upper limit of our integral, so we don't need to proceed with the integration process because the answer will always equal to 0. That one is the first property that you need to remember. Whenever we are dealing with the definite integrals, you have the lower limit and the upper limit equal value, then the answer will be equal to 0. Okay, for the second properties, if you have the definite integration with the lower limit b and the upper limit a of the function fx dx, okay, whenever you want to change the value of the limit upside down, you see the original one, this one is the upper limit, you want it to be the lower limit, and the lower limit you want it to be the upper limit. Actually, the answer will be the same. The different only the sign of your answer. If you calculate this integral, you get positive. If you want this integral, you will get negative. For example, I give you example for the second properties. We want to integrate from 0 to 2 x to the power of 4 dx. Okay, so this one is definite integration. So I just integrate x to the power of 4. I will get x to the power of 5 over 5. Okay, and the limit is from 0 to 2. So the first one, I substitute 2 inside my x. So I have 2 to the power of 4 divided by 5 minus, and then I substitute the value of 0. So 0 to the power of 5 divided by 5. So this one will be 2, 2, 4, 8, 16, 32 over 5. Okay, minus with 0. So you get the final answer is 32 over 5. Okay, but if you want to calculate from 2 to 0, you see the limit is upside down. Lower limit now become upper limit. The upper limit now become the lower limit of the same function x4 dx. So you integrate as usual, you will get x5 over 5. Okay, and the limit is 0 to 2. So the first one you need to substitute is the upper limit. So you have 0 to the power of 5 over 5 minus, substitute 2 inside here. So you have 2 to the power of 5 over 5. So here you have 0 minus 32 over 5. So 0 minus 32 over 5 is negative 32 over 5. So you see, the answer is the same. The sign is different. If you have this one positive, this one is negative. So whenever you are given, let's say question give you, okay, let's say we have question that give you, for example, given that the question give you, for example, given that the integration from 1 to 3 of gx dx. So gx will be any function of x. Okay, gx dx equal to 5. Question give you, okay, given that the integration of gx dx from 1 to 3 is equal to 5. Question asks you to find the integration of 3 to 1 gx dx. Question give you this information, question asks you to find this one. Okay, so you can see here, you are integrating the same function gx with respect to x. The difference between these two is the integral. This one is from 1 to 3, but this one is turned upside down from 3 to 1. So means that by using the properties of definite integral just now, the answer will automatically become negative 1. The answer is the same, the sign is different. Okay, so this one is the property number 2. And for the property number 3, this one is about the constant that involved in our integration. This one I think I want to explain because you will do a process like usual. Okay, for example, just now we learned about how we can bring the constant outside. Okay, it's similar. The properties number 3 is similar with the property number 5. So I will cover both directly. Okay, if you have the integration of any limit, let's say from 2 to 7 of the function 3x squared dx, okay, you actually can bring your 3 outside. Okay, so 3, you just need to solve the integration of x squared dx from 2 to 7. Okay, and the final answer later, you just need to multiply by 3. Okay, so this one is the techniques of integration that we learned just now, where we can bring constant outside of the integrals. Okay, and then if you see the properties number 4, it's similar to the properties number 6, where we can separately put the function into its own integral just now. Okay, like we learned just now. Let's say you have to integrate from any limit 2 to 3. You have 3x squared plus 5x cubed dx. So you can see here you have two different functions. Okay, the first function is 3x squared and the second one is 5x cubed. And in between of these two functions is the operation of plus. It only can be applied for plus and minus. Okay, so the operation is plus, therefore you can give them each one their own integral. So what will happen is you have the integration from 2 to 3, 3x squared dx, plus the integration from 2 to 3, 5x cubed dx. And then you can solve it separately, or you actually can solve it directly. So it depends on you. Okay, same goes if in between of two functions you have the sign negative. So it follow here the sign will be negative, but the methodology to solve is still the same. Okay, so this one is the property of definite integrals that is very important for you to understand, because sometimes we don't need to go through every process of integration if we have the information that can help us to solve our integration. Okay, let's see how we can use the properties of definite integrals that we learned before to solve a few examples of integration problems. Okay, so let's see the first exercise here. Given that the integration of the function f(x) with respect to x from 0 to 4 is equal to 5. So this one is the first information that you have. Okay, you can write it down here so that it will be clear. The first information is the integration from 0 to 4 of a function f(x) with respect to x is equal to 5. Okay, and then the second information given to you here is the integration of the function gx dx with respect gx with respect to x from 0 to 2 is equal to 2. So the second information is the integration from 0 to 2 of a function gx. This one function fx, this one function gx, means that is a different function, is equal to 2. Okay, and the integration of the function gx with respect to x from 2 to 4 is equal to -1. So this one is our third information. For gx with respect to x from the limit of 2 to 4 is equal to -1. Okay, class, now question asks us to find what is the value of integration of fx plus integration of gx from 0 to 4. So here we want to use the properties of definite integrals. So we want to solve the question A first. Let's find the value of integration of fx plus gx with respect to x from 0 to 4. Okay, from 0 to 4. So the properties that we can use is the properties that are two different functions separated by the positive sign here. So we can separate them by giving them each integrals. So what we have here is 0 for fx with respect to x plus 0 for gx with respect to x. Okay, you want to find the value. So you can see at the information that you have. Okay, information already give you 0,4 for fx dx is equal to 5. Means this one is equal to 5. No need to find anymore. It's given to you, the value. Okay, but now we don't have any 0 to 4 for gx dx. We only have 0 to 2, 2 to 4. How can we do? Okay, one more property that I think I left just now is one of the property of combining the integrals. Okay, so let's say we have the integrals 0 to 2, and then this one we have integrals 2 to 4. Actually, if you add these two integrals, what you will get is the integrals from 0 to 4, because you have a timeline, right? Okay, for these integrals, it calculates from 0 to 2. And for these integrals, it calculates from 2 to 4. This one. And this one, the first one. So, if you add the value of the first one and you add the value of the second one, what you will get is the integrals from 0 to 4. Okay, so now, in question, you already given the value of gx from 0 to 2 and from 2 to 4. So the value of integration 0 to 4, you can actually plus the answer here. 2, this one plus, right? For this one, 2 plus with the value of the next one is -1. Okay, so what you will get is 5 plus with 2 plus and minus is minus, 2 minus 1 is 1. So 5 plus 1, the final answer is equal to 6. Okay, the final answer is equal to 6. This one is for A. Okay, let's say B. Okay, let's see question B. If you are confused, then let's see question B. It might be more clear in question B. Okay, question B asks us to find the integration of 3fx with respect to x from 0 to 4, 2 to 0 gx dx, and 0 to 4 gx dx. Okay, class. We need to find the integration of 0 to 4 3fx dx plus with 2 to 0 gx dx plus with 0 to 4 gx dx. So let's see one by one. The first one, we can remember the property where we can bring out the constant outside of the integral. So what you have here is 3 integrals of 0 to 4 fx dx. Okay, and the value of this integral already given to you, which is 5. So you can just substitute 3 multiplied by 5 plus. Okay, now you want to find what is the value of integration gx dx from 2 to 0. We don't have any information, but we have the integrals of gx dx from 0 to 2. So what is the difference between these two integrals is just that the limit is upside down. You have here from 0 to 2, you want to find from 2 to 0. So just now, if in the property, if the limit is turned upside down, what you need to do, you just change the sign. Okay, if the answer is 2, now the answer will be -2. Settle the second part. And this one is the same with the previous one. You want the integration of gx dx from 0 to 4. So this one give you from 0 to 2. Okay, from 0 to 2, the value is 2. From 2 to 4, this one give you from 2 to 4, the value of -1. So if you want from 0 to 4, you just add up these two. 2 plus -1, you will get plus 1. So then we can solve this one. Positive and negative is negative. So 3 times 5 is 15. 15 minus 2 is 13. 13 plus 1 is equal to 14. So this is the final answer. Okay, so this is how we apply the properties of the finite integral to solve a problem related to the finite integration. Okay, let's see one more example here. Okay, so you are given the integration of function f(x) with respect to x from 2 to 5 equal to 3. Okay, so this is the information that have been given to you. Okay, the information is integration from 2 to 5, the limit is 2 to 5 of a function f(x) with respect to x equal to 3. This one is the information. Let's see what is the question asks you to find. The first one, A, question asks you to find what is the value of the integration for the function f(x) with respect to x from 5 to 2. From 5 to 2, f(x) dx. You have from 2 to 5, f(x) dx. Now the limit turn upside down. So what will be the answer? If this one is positive, this one will be negative. It's just that the difference in the operation or the sign of the answer. Settle. Problem number 1. Okay. Now question asks you to find B. Question asks you to find the integration from 2 to 5 of a function f(x) minus 2 dx. So when you have two different functions separated by the operation of plus or minus, you can separate them. Okay, you can give them each integral. So you have from 2 to 5 for a function f(x) dx. You minus with from 2 to 5 a function of 2 dx. Okay, this one no need to do any process because we already have the answer given to you here. The integration of f(x) dx from 2 to 5 is equal to 3. So this one is just put 3. That's one the answer. Minus, okay, how to find this one? Okay, do the process of integration as usual. Integrate 2, you will get 2x, and then you have lower limit and upper limit from 2 to 5. Substitute 5 inside. Okay, so you have 2 times 5, and then you need to minus with, substitute 2 inside. So you have 2 multiplied by 2. So 10 minus 4 is 6. So here is 6. 3 minus 6, the answer will be negative 3. Okay, with the help of the property, then you can solve the question easily. Okay, let's see question C, where it might be a little bit challenging for you. Okay, but if you understand the property clearly, then it's actually easy question. Just need to understand what question asks you to find, what question give you as an information for you, for help you to find the value. Okay, just now we have given the information here. Okay, we have the integration from 2 to 5 of the function f(x) dx equal to 3. This one is the information that we have. Question asks, what is the value of k if the integration from 2 to 5 f(x) plus kx dx is equal to 24. Alright class, this one is the critical thinking, but we will solve one by one. Use the properties of the integrals that we learned before, where the properties said that if you have two different functions, then you can separate both of them by giving them each their own integral. So now we give them their own integrals. So you have from 2 to 5 of the f(x) dx, okay, plus now from 2 to 5 of the function kx dx. K will be constant. So the value of this one is actually 24, given to you. Okay class, you have been told that the value of integration of f(x) dx from the limit 2 to 5, the value is 3. So you just need to substitute. Okay, but you don't know what is the value of this one, so you write it again. 2 to 5, kx dx equal to 24. Okay, now what you can do is you can bring 3 to the right, because this one is number, right? This one is also a number. So positive 3, you bring it to the right, it becomes negative. So what you have here, integration of 2 to 5 for kx dx is equal to 24 minus 3, which is 21. Okay, now we want to find the value of k. Okay, class. We have the integration from 2 to 5 kx dx equal to 21. Okay, so we need to solve this integral first, like usual. Okay, integrate kx. K is a constant, you just copy. X power 1 plus 1, it become power 2 divided by 2. Don't forget that you have the limit from 2 to 5. So this one is equal to 21. Just put 21 on the right side. Let's put it here. Let's put it there. Okay, and we solve this one. How to solve? We know that we need to substitute the upper value first. Okay, so it become k 5 to the power of 2 divided by 2 minus k 2 to the power of 2 divided by 2. Okay, so here you have 21. Alright, so we have here 5 to the power of 2 is 25 k over 2 minus this one 2 to the power of 2 is 4k over 2 equal to 21. Correct? So 25k minus 4k become 21k over 2 equal to 21. Okay, so you have here divide by 2, divide, bring it to the right, it become multiply. So you have 21k equal to 21 multiplied by 2, which is 42. Therefore, k is 42 divided by 21, which is 2. So we have the value of k. Okay, so this is how we solve a few problems related to integration by applying the properties of definite integrals that is somehow important for us to really understand. Okay, to help us in solving the integration question or integration problem. Okay. Hello everyone, so you have complete topic 5 calculus, which cover the techniques of differentiation and integration. I hope that every knowledge that you learn in this topic will help you out when you need to solve a related problem. So don't forget that you need to go to the topic 6, which is the demonstration of the scientific calculator. Thank you so much for your attention and cooperation. See you again.